Our next speaker is Michael Hussain, who's from Hussain Architects, and they actually, making a connection there, designed the St. John's ward there in Crumlin Hospital, and they also did the Europa Hotel in Killarney, which is a beautiful building. And I suppose like designing and using 3D spaces for architects. So, hi, Michael.
Hello, how are you?
Good, very good, thanks. So Michael's going to tell us about doing this. So I'll pop off here.
Can you see my screen?
Yeah, we can see it good. Yeah.
Okay, perfect. So briefly about myself, Michael Hussain. I have a degree in master's degree in architecture and digital architecture specifically. I studied in Slovak University of Technology, and I moved to Ireland like 6 years ago. And I've been with Hussain Architects for the last 3 years. I will briefly, just a moment. So briefly, I'll go over the challenges in architecture practice, specifically communication challenges, potential VR assistant to help with those challenges. I will also go quickly through how the design development process is created in architecture, and how VR becomes part of it. Challenges and limitations, and some samples for us to see. And if you have any questions, I'll go through them. So one of the biggest challenges in architecture practice we have is like to communicate the ideas that we have with clients. Many times we realize the clients, they cannot exactly imagine the spaces or the ideas based on our drawings, which are most of the time 2D drawings. So this is a big challenge that we always face. Also, the clients, they usually cannot imagine the materials or the shape of the space, or the lighting of the space, and as well as the size or the scale, which is a big problem. We also face big, sometimes problems in ensuring like communication with different designers and contractors. So with VR, we are able to show more in detail these ideas. And the way we build our models at the moment, we move towards 3D modeling in softwares like Revit, which are building information modeling. And we model basically 1 to 10 in scale 1 to 10 usually. So our models are pretty well designed. So we implementing the VR into these models is not a big problem. There is a big technical complexity in our projects, commonly over-engineered, and we have multiple designers working on the same project on the same file at the same time. So there is quite often clashes between the designers. So using VR, we are able to go to specific points of the building, observe where the clashes happened, and work on those in detail, and see where is the issue and how we sort it out. So VR help us in our practice and architecture, help as a design process. We are quickly able to, as soon as we have basic shapes of the building, we are able to go into the model and see roughly the scale of it, how it shadows the surrounding buildings or the site or in the environment, how it affects it. Sometimes it's just white plain boxes that we just place into the site model, and then we can see how it affected. Also, it gives us, even for architects, sometimes the imagination of the space. If it's very complex, sometimes we struggle with imagining the space itself. So whenever we are going to the model, we can see the design flows, the changes that we can make, and the lighting of the space, for example, is a big aspect of it. The way materials and colors change the space, and all those effects. So as I spoke earlier, that in architecture we work with a very big team of consultants and designers, and nowadays it's all been moved to BIM softwares. And those software, each of the consultants, they build their own model, and then they are all united into one central model, where you can see the clashes, as I mentioned earlier, and as well, like you are able to generate the drawings. Meanwhile, everybody's working in the same file at the same time. We are able to generate the drawings and see the progress at any time. It gives clients a great sense of the space and experience it before it's being built. So it gives very good sense of the space for the clients, as they don't always understand the 2D drawings. They get to experience the space, they get to see what they like and what they don't like, and if they are not happy about something before being built. So it's very important for the clients to actually experience the space before being built, and then realize they didn't like something about it. It's time effective, also cost effective. As I mentioned, you don't need to do the design changes later on site, so you can do them and you can experience the design beforehand. So many times you would be on site, and then the clients, they are not happy about something, they would like to make a quick changes, that would be too late or would be expensive to do that. Yeah, so quickly about design development process and architecture. Usually we start at very simple sketches. And these days, those sketches we still do them, but then we quickly transform into 3D softwares, where we just do rough shapes to see how it is. Then we go, as we agree about the shapes, as we are happy with the way it presents itself, we go into more detail, and then we generate elevations and floor plans and 2D drawings with all the spaces that we are designing for. And you can see the dimensions of the space and so on, what parts of the buildings, its structure, and so on. Back in time, we used to do physical models. Nowadays is very, very rare to actually have physical models. The problem with the physical models is they are very time consuming, and they're also quite expensive to be made. So nowadays, as you have the VR, you can go into the space rather than just looking around the small scale model, trying to imagine the space. They are still very useful, very helpful, but nowadays we don't use them as much because the 3D softwares, they replaced it. The challenges of using VR are, it can be quite intensive process to actually make the models look good, because many times while we are in a design process, which takes maybe a year or two, you don't have really finalized models, so you are working on a in progress model which might have some flaws, and to actually achieve something that really looks good or convincing for the client, you have to spend extra time on it, adjusting the material. Sometimes you don't really know exactly what materials the building is made from. You are at the early stage, but you are trying to kind of apply some materials without really thinking about it in depth. So it can be time intensive. It adds a bit more extra time to prepare the models. You can, as I just mentioned, you can also see the imperfections in the model as it's in the design process. It's not done yet, so you can kind of see the flaws of the space or the model itself, which sometimes raises questions that didn't need to be raised by clients or builders or whatever. But as we keep kind of clarifying that those models are in progress, and you have to point out a specific part of the model. And there is also, as you go into VR, you kind of go into more detail. So adding extra detail adds more complexity to the models, which might make them heavy. Depends on the size of the building or the site. It can make the models very heavy and very hardware intensive. So as we use BIM, we can actually work. We basically nowadays we use it almost every day. That we have one screen that we are working on modeling and drawing in it, and the other screen that we show. We see the progress of the model, which is synchronized automatically. There's several ways of using VR and architecture, but we do as a plugin. We use Enscape inside Revit, so we don't need to always transform the model from a software to a software. It's all done in one software, which is great. You can see immediately the changes, the effects, the material changes, and you can keep continuing doing your drawings while you see the models being updated. I will show some case studies and examples. We produce animations. This is not specifically done by our practice, but this is a good example of where animation is produced in Unreal 5. So you can see the detail of the models being made. It's nearly one-to-one scale. This is like a very well done model, but you can really see and feel the vibe of the space, and as well as the impressions of the materials, the lighting, and so on. The textures, the type of the wood, planting. For example, even adding a skylight, the effect on it on the space, above the bath, or above the shower, which effect it gives to the space itself. So then we do virtual walkthroughs, which are basically you are walking through the model. You can experience it. You can experience the materials. You can add sound effects. You can see um, the daylight, nightlight. Uh, you can actually feel the space and how it looks. So it really gives you the possibility to experience the space before you actually build it, which is really great. Recently, I had to do a project on the Hotel Europe, and I was working on a swimming pool extension there. And actually, previously, I haven't worked on this project. And as I modeled the space, I did some extensions for the pools and variations for it. And then later on a site visit, I went to see the pool itself, the way it was looking, and I was very surprised how accurate the feeling that the VR gave me compared to actually the build space. It was very accurate. It didn't surprise me. It felt like I have seen it before. As you can see the details. You can see you can think about details while you're designing the process, the effects, the sound, the sunshine and light. You can also change the artificial light inside the software. Sorry. So From there, we have also like example of how we are able to change the materials inside the software itself. You can see example of changing the software material and the effect of it, and so on. Sorry. And this is also another example of, for example, changing the kitchen materials to different type of stone or different color or different texture. You can also change the color inside the software immediately, so it's great. Like you can directly imagine the results. You can see the actual results, how they affect the space. If it's a light software, it's a dark, it's colorful, it always. So it's a more practical way of seeing the changes, the actual changes in the space. So this is another study we did. We did lighting for this project. We had this timber structure for this extension, and we have this timber fins on the roof. They're above the walkways, and we are studying the effect of the sun during the day, during specific times of the year, and the way the shadow drops on the structure, how we experience it from outside and inside, the views that you have during the day, how the space changes from different perspectives. We usually export those views and we give them to the clients, which they can see them on their time. They can review them if they like them or not, and so on. This was another project we did. It's a big storehouses. We are studying the elevations. There we were cutting. We were studying how to break down the facade without adding multiple colors or multiple materials onto a same facade. So we did a light study, and we put multiple panels with different shapes, and we saw like the effect of the sun on those reflections of the panels, how they break up the shape without changing the colors. So throughout the day, the building shape changes the expression of itself. Sorry. We also, this is for example a collaboration project we did. This is for the same project, this is for the same unit, and we have the structure model made by a structure engineer, and we did the shell, and it's all together. It looks like it's a collaboration project, so you can see the details adding up all together. This building was this is planned to be built from glulam timber structure, uh, and it's very progressive. We share those models in our meetings. We review them. We see what we could change. For example, this model is a bit outdated, so we changed the color of the purlins on the roof, and to timber purlins. They were previously steel purlins. So That's basically it from my side, I think. Yeah. So that's basically it from my side.
Thanks, Michael. That's amazing. You said it there. Experience the space before it was built.
Yeah,
Say a lot of clients like that.
we are trying to achieve that. Yes.
I just got two questions here from the audience. So for all the variations of material, then it's supposed to like changing the couches and the uh, tabletop and stuff like that. Does it generate it live, or does it need to be?
Yes, you can do it live. So this was the example that I showed was done in Unreal. Uh, they have different settings, and you can also do it live there. We use Enscape with Revit, so we kind of adjust it in Revit, but we see on the other screen that is already updating, so we immediately see the progress. It's very very quick.
And just one last one there. Sarah was just asking. You said a few applications there. So Revit. What were the other ones that you were using?
We use Enscape mostly for rendering. Yeah. I can write it down in the chat.
Do please, yeah.
Will do.
A lot of people are interested in the software that you use. That was excellent. And I suppose the clients must love this, do they? Or is it good for?
Yeah, actually they do. Yeah, they do. It really changes because many times when they see the floor plan, they don't feel so excited.
Hard to tell. Yeah.
It's hard to imagine. You can't really realize how they don't really understand sometimes the space. So we are very used to it. So we always have to kind of remind ourselves that we actually they cannot really imagine the space the same way. So we always try to translate to them, communicate it to them.
And I saw Balbriggan, Finglas, Fingal County Council are redoing Balbriggan, and they made the seafront there, and they made a 3D model, and they were saying that they got a lot more feedback and a lot more enthusiasm from when they show those models in the foyer of the council and people come in to look at them, but this one they're able to go and walk around it, and they found it increased the enthusiasm for it a lot.
For sure. I mean, for someone who's not really interested in this field, I assume the 3D visualizations or the VR is the closest they can get to it to understand it.